Okay, next we want to review this parts of a system. We're doing systems review from first semester 2013-2014. Okay, so as we're thinking about systems, uh, we're wondering if some object that we're interested in, would it be helpful if we thought of it as a system? Uh, so it helps to know that all systems have inputs. So the stuff that goes into a system, or uh, the matter or the energy that causes the system to start working. If this isn't there, the system isn't working. If this isn't there, nothing's happening with the system. So that's inputs. That's the first part of a system. Outputs. Systems tend to have matter or energy or information or some product or something that it produces when it's working. Um, in fact, if a system isn't got this output, then you'd wonder if it's working or not. So, for instance, uh, if my car isn't running, then I'm wondering if it's not working. Okay, so because it's not getting me down the road, or my bicycle, or whatever. Uh, Components. These are the subparts or the pieces of a system. It makes a system work. Uh, when you take a look at something that is a system, it's often very true, unless it's a very simple system, that it's not just one big piece that does everything. If you take a look or take it apart, you'll find that there are pieces in that system. There are pieces that communicate with each other or they function together to make something happen. That's what we're talking about with components. It gets confusing for people, but I think that the point is that you don't have you don't often take stuff apart. If you don't take stuff apart, then you don't see what's inside. If you don't see what's inside, you don't realize that most everything that we have is made up of pieces. Even a pen, a clicking pen, take it apart. There's a spring, there's the pen piece, there's the knob at the top. These are all components, parts of a system. Boundaries. One another words to think about with boundaries. There's the limits, the extents, or the limitations. Uh, your hair straightener can't curl your hair too. I mean, it has a limitation. It's only for straightening, right? Or your blender in your kitchen, it only blends. It doesn't toast, right? So it has boundaries, it has limitations, it has things it can and can't do. We also talk about the edges or walls or container of a system. That's all boundaries. Okay. And then equilibrium. Equilibrium is just a fancy word for balance. Uh, when we say a system is in equilibrium, we mean that it's balanced. It's not changing. Think of a teeter-totter or a seesaw, right? It's not changing if it's in a balance. So the force of the person sitting on one side is equal to the force of the person sitting on the other side, or the torque, the weights. Uh, it's not moving. And in fact, if you were to walk away from something that was in equilibrium, then come back, it'd look like you'd never left, right? You wouldn't be able to tell if there was any difference. It would look the same. That's what we're talking about with equilibrium. So when it comes to equilibrium, we differentiate between two different types. Um, Dynamic equilibrium or static equilibrium. And being able to tell those two apart, that's a level 2 requirement for the standard. So let's talk about those. So my types of equilibrium. Dynamic equilibrium or static equilibrium. And here's how it breaks down. You have input to the system. You have output from the system. So the system is like running, right? But it's still in a balance. It's not changing significantly. I mean, the system seems to be okay. So that's a dynamic equilibrium. A static equilibrium is no input, no output. So boring almost. But the system isn't a balance. I mean, it's not changing significantly. If you walked away, it wouldn't look much different when you came back. Those are equilibriums, both of them, but they're different. So think of dynamic equilibrium as like normal operation. It's system's doing what it's supposed to be doing. The bicycle, as you pedal, is moving down the road. It's the dynamic equilibrium. It's not falling over. It's not changing significantly. It's just kind of doing what it was supposed to do. Whereas if your bicycle is sitting there, leaned up against something or parked, it's off in a sense, right? There's no input. You're not pedaling it. It's not moving. There's no output, and yet it's in equilibrium. It's fine. It's just sitting there. So that's a static equilibrium, dynamic equilibrium. Uh, it's all pretty theoretical. Let's look at an example. So here's my example. And you know what? Uh, I did this in my classes, and you might have seen it before. But let's not talk about the inputs or outputs right now. Let's just look at the system. Okay. So here I've got a spigot, right? It looks like this is kind of where water might come out if I turn it on. It looks like the water, when it comes down, it'll probably hit this wheel here and maybe turn this wheel. And I'll say right now this is a generator, so that's going to convert mechanical energy into electrical energy. Electrical energy is going to flow along that black wire there, and looks like it's going to go into something that's maybe it looks like it's kind of a stove, part of a stove. So there's water on the stove in a pot, and then there's a thermometer telling me what's going on with the water. So I'm thinking this system has some components here that are separate pieces, but as a whole, it's a system. So it doesn't look like this system is going to toast. It doesn't look like it's going to toast anything like bread. It doesn't look like, so those are limits, right? Those are boundaries. It doesn't look like it's gonna turn on a light. It doesn't look like so you can see kind of the limits. It look like this electricity, it's only gonna go to this thing here. Electricity is not gonna go someplace else. And it looks like all the heat is probably gonna go into this water, and it looks like this water maybe doesn't have a lid, so maybe the steam is going to come out of this pot. So we're thinking about boundaries, we're thinking about the components, and that all before we've talked about inputs or outputs. So now let's see. It looks like I can turn this on right here. So let me give it a little bit. Okay, it looks like when I turn it on, water comes out, and I can turn it off. And it looks like the thermometer went up a little bit. This is a simulation of a system. I can turn on energy symbols now. So check this out. If I take a look, I can zoom in over here. I click this checkbox here and it turns on the energy symbols. I have 5 basic types of energy. There's mechanical energy, kind of grayish, electrical energy, blue, thermal, kind of red, light energy, yellow, and chemical energy, kind of green. So let's see what kind of energy. So we're not talking about energy in this video, but it might help for us to see kind of what things are happening when I turn on this water. So as I turn on the water, it looks like mechanical energy is coming down through the water. And the mechanical energy is hitting the wheel, and that's putting mechanical energy into the generator. And it looks like the generator is taking mechanical energy here, the gray, and turning it into electrical energy. It looks like this electrical energy is coming to the stove, and it's turning into thermal energy. Thermal energy is going into the water. Water is heating up, so that's being measured by that thermometer. And it looks like there's steam coming off the water, so the water's hot enough, it's probably boiling. And there's thermal energy going through the steam, so out of the water, out of the system. So, so my input is water. My output is steam or heat to another bunch of water over here. So we've talked about inputs, outputs, we've talked about components, we've talked about boundaries, now equilibrium. So if I imagine that there's water boiling over here, and there's kind of water vapor coming off here, so steam, but this is turning, that's fine, constant speed. This electricity is flowing kind of constantly. This is an equilibrium, it's a balance. So I've got water, thing turning, energy coming over. If I were to go away for like a few minutes and then come back, the system would look about the same. Now, okay, you know, or you're saying to me, hey, you're probably going to lose water over time. That water's going to be gone. Okay, but for the time being, it looks like it's pretty much a dynamic equilibrium. There's energy going in. Sorry, there's input going in, and then there's output. There's heat or steam coming out. Okay, and the rest of the system's not really changing. So let's try a static equilibrium. That means I've got to turn off the input, no input. And I think if we let it cool down enough, there won't be any output. In other words, the water will basically stay at a certain temperature. Okay, so the water's pretty hot. We might lose a little energy, but this is another equilibrium. I've got hot water. It's getting a little bit cooler. Okay, over time we're maybe losing a little bit of energy. But this is a static equilibrium. Things are like off. There's no input. There's no real output right now. So you could describe this as a static equilibrium. Inputs, outputs, components, boundaries, equilibrium, static equilibrium, or dynamic equilibrium. That's what we're talking about when it comes to systems. So let's give this a try. We'll go back to our PowerPoint here. We were talking about an example, and now let's apply this example using the systems frame. The systems frame basically says, define the system. I give you something, a child on a swing, a crazy water wheel heating up some other water on a stove type thing. You tell me what your system does, describe it, what starts it, what it does, what its parts are. Then you basically tell me what it does, its parts. All right, what it does, its parts. What makes it start? What are the limits or boundaries? And then when is it balanced? That's equilibrium. So we're using slightly different words, but you tell me what your system is here, what your system here, and then tell me what your inputs are, what your outputs, what your components, what your boundaries are. And then describe to me both a dynamic and a static equilibrium for your system. Okay? So here's the systems frame. I'll let you pause the video. Do it for the system we just did. Maybe rewind or go back and see if you can come up with it. And then if you play through my description, you should have things written in your systems frame that we had talked about. So I'll give you 5 seconds to basically pause this video. Okay, we're back. So we fill in the systems frame. So what we've got is the this is the water wheel and the stove. My input was falling water. Notice that water that doesn't fall doesn't have energy to turn the wheel. My output was steam or heated water. Let's write this in there. My components were my generator, my water wheel, my heating element, right, because I had to heat my element. The electricity from the generator went somewhere to a heating element, looked like a little stove piece. And then my other water, my pot of water, and apologize if you can't read this. My boundaries were, let's see, I had water flowing in, and I had steam coming out. So basically, I had a limited amount of water on the stove, so I had a pot. The water couldn't get out of the pot. It couldn't get onto the burner, steaming, all this crazy stuff. And it looks like maybe if I had a bunch of water, I probably couldn't heat that all up just with that little bit of electricity. But then I'm kind of using my imagination here. What are some things that are limiting my system? And then my equilibrium dynamic was wheel turning at a constant speed. Water basically at a constant wheel turning, and my water was heating, or my water was heated. Well, water boiling. Water that's boiling, here's a quick fact, is staying at one temperature. And so you're basically just driving water off as steam molecules off. Static equilibrium was when I turn off my water, and I basically have the wheel not turning, my water staying at a certain temperature. When it's hot, it cools down, of course, but if it's just room temperature, it's fine. And so that's an equilibrium. If I went away and came back, I wouldn't know anything had changed. If it was turned off, it wouldn't be getting hotter, it wouldn't be getting colder. All right, so we filled in the system frame. So far, this is where we're at in our learning progression. We've evaluated the input and output of a system to determine if it's in equilibrium. We've identified static and dynamic equilibrium. Next, we need to talk about, with a system, if it has positive or negative feedback. In other words, how output might affect input, and then we can do a quick comment here on level 4 of our learning progression. So that's it for this video. Take a look at the next one to talk about feedback.